All right, everyone. This is a video to kind of help you on the lesson 3 practice problems. So your practice problems might look something like this. I might go over some of them. So let's dig in. So I think some of these, like number 1, 2, 3, 4, 5, those are kind of just basic recall. Like, can you remember the answer? Number 6 might be an actual procedure where it might be useful to go over. So in this case, we have a question: how much power is produced from a person that does 710 joules of work in 6 seconds? So from here, you might want to think about what equation you use or things that you might know. I always encourage you to write down what are the things that you know. I know the work is 710 joules. I know the time is 6 seconds. What I don't know is the power. All right. So there's an equation that we might use, that you should use from your notes. Power is the work divided by the time. So with that equation, we just do power is 710 divided by 6. All right. So let's do that on our calculator real quick. So we get 118.3. And the units for power are watts. So sometimes we could just write a W, or we could put the whole word watts. All right, let's do another one. This one is very similar, where you're given energy and time. So I'll just give you the basic setup for this one really quickly. So I know that the energy is 870 joules. I can see the time is 8 seconds. And again, the question is asking for power. So you're going to want to use this equation. Power is the change in energy divided by time. All right, so that's the setup for that one. I'll let you kind of do the rest, but I think from there it's pretty easy math. All you have to do is divide something. Let's do this other one, number 8, which might be a little bit tricky. So number 8, it says how much energy does a 100-watt light bulb use in 40 seconds? So what do we know? Well, the question is asking for energy, so we don't know energy. What we know is the light bulb has 100 watts, and watts is a measurement of power, so we know the power is 100 watts. We know the time is 40 seconds. What we don't know is energy. All right, so we need an equation that combines these things. We're going to actually use the same one. We're going to use this equation, same one as the last question. But what we're trying to find is a little bit different. So we have power is the change in energy divided by time. All right, but here are the numbers that we know. We know the power is 100. We don't know the change in energy, but we do know the time, which is 40. So in a situation like this, if you're trying to find this variable and you have this denominator, we want to get rid of this denominator by multiplying both sides by the denominator. So we can multiply both sides by 40. Multiply this side by 40, multiply this side by 40. Multiplying by 40 and dividing by 40, those cancel out. And now all we're left with on this side is the energy. Energy is going to be equal to 40 times 100, which is 4,000. Remember the units for energy is joules, so we write a J for joules. All right, let's do one more. So this is one that I think is important. Actually, let me just do number 9 really quickly. Number 9, convert 58 kilowatts to watts. Okay, well, one thing I know is that 1 kilowatt is equal to 1,000 watts. So if I want to convert kilowatts to watts, I just need to multiply this number by 1,000. I think another way that we can do that is we can say, all right, I have 58 kilowatts. This is a common way that it might be shown in a textbook when it comes to converting units. And I want to get that into watts. So what I'm going to do is I'm going to multiply it by the conversion. The conversion is 1,000 watts in 1 kilowatt. All right, so this is our conversion. There's 1,000 watts in 1 kilowatt. Well, I have kilowatts in the I have kilowatts over here, but I also have kilowatts in the denominator. So those two units will cancel out. So what I have is 58 times 1,000, and the units I'll be left with are watts. So I get 58,000 watts. All right, so let's go on to this table here. So this is a table, and this is something that I think is useful because when you look at the information online, you might be given lots of different numbers, and I want you to understand what to do with these numbers and what they mean. All right, so here's an example of a typical classroom. We have lights in a classroom. I have a laptop, a pencil sharpener, a TV. And so we're going to look at this data and we're going to try to figure out how to interpret this. I have watts for each object, but then I also have the number of those things in the classroom. So this classroom might have 20 lights in the ceiling. There might be one laptop used by the teacher. There might be one pencil sharpener. There might be one TV. So we can multiply the watts of each item by the number of items, and that gives us the total amount of watts. Okay. From total watts, what we can do is we can divide this number by 1,000. If we divide this number by 1,000, we can turn it into kilowatts. So you can see that a lot of these numbers look very similar. All that we did was we just moved the decimal over 3 spots. Or another way to say that is we divided by 1,000. So the kilowatts is shown here. And then the last thing I'll show you is we can multiply the kilowatts by how many hours in a day is this object used for. So for example, the TV in the classroom might be used for 8 hours while the students are there. The lights might be on for 10 hours while the teacher is there and the students. And the pencil sharpener might be used for like 6 minutes during the typical day, depending on how many times the student sharpens their pencil. So if we multiply the kilowatts by the hours, we get these things called kilowatt hours. All right, and you might see this unit a lot when you are doing research, kilowatt hours. And again, all you do to get that number or where it comes from is it's the kilowatts of an object multiplied by how many hours it's being used for. All right, so which item uses the most power? Well, power is measured in watts. So I can look at this list here and I can easily see that the TV uses the most power from this list. All right, so if I was going to write a sentence, I'd say that the TV uses the most power. I can see that the TV uses 200 watts, which is the most from this list. And then this one says, which item has the least total watts? So I'm looking at my list over here, the total watts. And I can see that the laptop uses the least total watts. Okay, so this would be, I would focus on the TV and this number right here for question 1. I would focus on the laptop right here for question 2. Okay, and there might be another question on your practice problems about the kilowatt hours. So you can see here in this example, the lights of a classroom ends up using the most energy by far. I mean, the TV uses a fair amount, but the lights actually use 4 times as much energy. I can see that 6.4 divided by 1.6 is 4. I'll write that down because that's important. It's important to think about how much more energy is one object using than another. And we could say that the lights use 4 times more energy than the TV. All right, so this video is kind of getting a little bit long here. I don't want to take too much of your time, but I do want to give you some examples of how to solve these problems. And I do want to emphasize the importance of understanding your units. So watts, all right, kilowatts. Kilowatts just means 1,000 watts. And we can convert this by dividing by 1,000. You can take your kilowatts and multiply it by 1,000 to get watts. So you can convert from one to another. And then you can multiply the kilowatts times the hours to get this unit called kilowatt hours. It's a very important unit for energy that you might see when you do research for your energy project. All right, I'll stop there and I'll see you in class.